So I'd like to go over the idea of constructors, and I really want to sort of reinforce why we would want something such as constructors, and what would be the merit behind having constructors. And there are actually two main rules we'd like to sort of attach to constructors, and these rules sort of really reinforce what a constructor is. And so I'm going to go over to my IDE here where I have my main method just opened up, waiting to sort of execute something. And so in extension to my main method, I have a class, and you could have as many classes as you want. And the class we want to remember is but the template for a potential object. Now we know that a class sort of encapsulates instance variables, methods, and a constructor. Now, we know that methods are simply functionality, or rather abilities that can be sort of executed by an object. And we know that instance variables are actually properties, attributes, characteristics, or states of a particular object. And all these words are sort of synonymous for one another. And so they all sort of mean the same thing, that an object could have features. Now, we're not really dealing with an object yet. We're actually dealing with the blueprint or a template of an object from which we can actually draw from when a potential object is created. And so if we have a person class, we too in the main method can have an instantiation of the person class, such as if we had a person class, we could have a person. And this is sort of the syntax you'd want to follow for actually creating a person or reference an object. And essentially what this does is it references the collection of methods, instance variables, and constructors which are available to the object. And so as soon as you create one of these objects, and what they ask is, of course not verbally, but what they ask is, what is available to me? What do I know? And so when this comes into existence, it says, do I have a name? Do I have features? Do I have methods? Do I have, or abilities rather? And so this class here just says, well, yes, you can have either three. And so just for the purpose of this here, let's deal with instance variables. Now, instance variables, again, are sort of those features, those characteristics. And so I can give my potential person or my potential object, which is actually a person, a name, and I can also give it an age. And so now this object knows that, well, I have a name and I have an age available to me, and I can actually reference this in order to sort of make this object unique. Now, if I were to simply just, let's see, if I were to simply just print out sort of the name of this person, again, the name isn't initialized to anything. So if I print out if I reference the object, I first reference the object, and then I reference the sort of the instance variable, which is the name. And in conjunction to that, I'd also like to reference with a space, of course. I'd also like to reference the person one dot, let's see, I had an age, right? And so printing both these out, I mean, this is completely fine, but recall that with a string, the default is null. And so if it's not initialized to anything, it's really just null. And the same thing goes with age. I mean, if it's not null, but it's actually 0. So by default, these really don't hold any possible values. And so when we print this out, the name and age is actually null. And this works. I mean, this is fine, right? I mean, we would know what object we're talking about if it gives us null and if it gives us 0, because we know what we're talking about this particular object. Now, really the problem arises when we have person 2 equals new person. And this is sort of the problem here. And the problem is, okay, well, this is actually supposed to be 2, but the problem is if we were to do the same thing, I mean, follow virtually the same steps for person 2, and since we're dealing with person 2, let's just change the reference to person 2. If we do the same thing with person 2, essentially, again, we would get null and 0. And so this is actually the main issue here, that we actually can't differentiate between either of these objects. We can't say person 1 has an object, or rather a name and an age unique to it, and we can't say person 2 has a name or age sort of unique to it either. And so what we want to do is we want to somehow initialize these instance variables that we have for us, and we do this by constructing these initializations. And so that's really all it is. And so what we do is we create a constructor, and that's usually how a constructor looks, not to be confused with a method. Again, a method is sort of the functionality in the constructor, or whereas the constructor actually initializes the instance variables that we have within our class. And so what we do with our constructor is, well, we say, look, I'm going to pass in a name, and I'm going to also pass in an age. And what you realize very quickly is that the variables which are sort of which are observable on the class level are sort of the same variables which are used on the local level. And the local and global, these are just scopes used to sort of differentiate between whether or not a variable is accessible within each and every method, or whether or not it's sort of accessible within the closest braces which are confined to it. And essentially what I mean by this is the closest braces which are confined to it. And again, I repeated this, but I'll just sort of repeat this just so the visual example is clear. We have the closest braces which are confined to it. So all of this is sort of confined within its closest braces. And so that includes the string name and int age. And so that sort of allows us to observe the fact that while age and name are sort of accessible on the class level, string name and int age are completely different. And so these are treated as different variables. These are the local, these are sort of on the smaller scale, and these are the global on the bigger scale. And so to differentiate between both of them is very important, because what we want to do is we want to find a commonality between them. We want to say, well, we want to say that this name is equal to the name that we find on the class level, or rather the class level is the same name that we're referring to on the local level within the parameters. And this is actually called a parameterized constructor. And this dot age is actually equal to the age that we're finding on the in the local level. And so this sort of allows us to sort of tinker with these variables and sort of reference them in the same manner, such that whenever I'm talking about this name, or whenever I'm talking about this name, I'm actually talking about the same name that I intended to talk about, and that would be the same name that is sort of exclusive to person one. And so what this allows me to do is, now that I've sort of stated that I may be able to pass certain things into the person constructor, I'm no longer dealing with an empty space between both of these parentheses. That is to say, now I'm dealing with a name, and now I'm also dealing with an age. But of course, they're not generic as I've listed. I can also, in this case, not also, but I can only, what I can do is I can sort of give I can give a name here. I can actually type a string in that is sort of unique to the object, just because I've actually sort of specified that within the constructor before. And so what this allows me to do is it allows me to give a name and an age, as well as giving in a sort of another name and age, which is sort of unique to object 2, person 2. And this can be Ashley, right? And Ashley can be 4 years old, younger than Jerry, but sort of approaching the age number 5. But and so essentially now when I do this, when I print both of their respective details, you can see here that I actually have 2 different unique things that are not sort of exclusive, which are sort of not the same between person 1 and person 2 like I had before. And so this allows me to sort of tinker with those names. Now, essentially, one thing you want to remember about the constructor is that although this is all fair, we can notice that a person constructor actually has no no written type. That is to say that we don't see a void or really a return type sort of before or prefaced before the constructor, as we would with a method. So for instance, if I wanted to make person 1 talk, I would put void and then talk, and then within this talk functionality here, within this talk method, I would sort of say, okay, just because they're younger, I would just say child noises, right? And so essentially, I mean, so this is a method, right? If I don't specify a return type, it's going to throw me an error, and it's going to say, well, you have to specify a return type. A return type to the method is missing. And so I can either say, well, it returns a string, right? In which case it must return a string. Or I could say, well, it's just void. It doesn't return anything at all, and just like this one does. And so that's a method. Now that I can't have this to sort of carry out the same function as the method described below. If I were to say, okay, I'm in the constructor, just to signify that I'm actually in the constructor. I'm in the constructor. Now, if I were to make the person object, which I have, and I were to um, sort of, so this is the default constructor. So it's really applying here with the default constructor. And so when I print this out, it should say I'm in the constructor, right? And so I'm in the constructor, but the thing is, if I were to do void, then void is essentially signifying that this is not a constructor. This is in fact a method. And so the method essentially says, well, now it's not going to print anything out because it's a method. It's not a constructor. And so that's really an important point to remember regarding constructors. And we could also have, and so we always want to sort of make sure that we don't have any written return type. It could be private. It could also be public. Um, it could be a wide range of things. It could be protected as well. But really, my main concern here is just to not confuse the method for the constructor. Again, usually what happens is we have like a proper form here where we start with instance variables and then we migrate to constructors which initialize those instance variables. Again, chronologically, that makes sense to follow one with what comes before it and which is pertinent to the one that comes before. But and so then we have our methods, and so that's really the thing you want to remember. Now, can there be a method which has the same name as a class? Absolutely, absolutely. And there can also be another constructor. Again, we could have one constructor and another constructor. Okay, but maybe that's not applicable, but I think I know that you can have two constructors here. Yeah, you can have two constructors as sort of overloaded in that sense. And there's a whole host of reasons as to why we'd want to do that. Maybe we'd want a default object, sort of a default constructor, just so that we're not always forced to put the name within you'll see here that if I take off my default constructor, it forces me to put a name in. I have to put a name, which is why it underlines it. It says, well, put a string, just like you said. And so if I don't do that, I can't really interact with the object. So in the instance that I want to interact with the object, maybe I just sort of make a default constructor to take care of that eventual scenario there. And so, I mean, this sort of summarizes what you want to know about constructors. But there's also something we'd often find called super. And there's the super keyword, but there's also something called the super class. Or sorry, the super constructor itself. And so we have a person here, and the person may be like, it could have a name, right? But of course, before having a name, before having a constructor which sort of gives it a name, we'd actually want an instance variable which actually does that, or rather makes the name available. And so this dot name again is equal to name, just to make sure that we distinguish between what's on the class level and what's in the global, or rather the local level. And so once we do that, we can actually just create another class in the case that we wanted to. And instead of this being like a person, obviously it wouldn't. We're specializing as we go down in the hierarchy. And so instead of this being a person, it would be an employee, which is actually just an instance of a person. And so we can extend person here. And so everything that is available within, everything that is sort of available within implicit super constructor applied. And so essentially, if we don't mention anything, for instance, if we don't say that there is essentially what it's saying here is that we have to have super, and super will sort of take in person. And when we have super, we can pass in a name, like Jerry, for instance, and that would be applicable. Actually, I don't know too much about super yet, but when I do, I'll certainly make a video which sort of broadens on that aspect. But for now, I think we're absolutely fine with constructors.